So now we will solve question number 6. So in this question, it says that the line L1 has equation 3x minus 4y plus 20 equals 0. The line L2 cuts the x-axis at R and is parallel to L1. And part A says find the equation of L2, writing your answer in the form ax plus by plus c equals 0, where a, b and c are integers to be found. So as we know that generally to find an equation we need two things. One is passing point and another is gradient. So the question already mentioned that the line L2 passes through R because it cuts x-axis at R, so we need the gradient. And the question also says that L2 is parallel to L1, so if two lines are parallel then their gradient is same. So from this equation we will find the gradient of L1 and we can use the same gradient for L2. So 3x minus 4y plus 20 equals 0, so which gives us 4y equals to 3x plus 20. So subtracting y we get 3 over 4 x plus 5. So this is the gradient for L1 and also for L2. So for part A, the gradient of L2 is 3 over 4 and passing point, that is x1 comma y1, is basically the point R, that is 8 comma 0. So equation of L2 is y minus y1 equals to m into x minus x1. So y minus 0 is equals to m, which is 3 over 4, x minus 8. So if we cross multiply we get 4y equals to 3x minus 24. So simplifying it, it gets us 4y minus 3x plus 24 equals 0. So this is the equation of line in the required form. So for part B, the question said that the L1 cuts the x at P and the y at Q. So first of all, what we have to do, we have to find the point P and the point Q, and then we can find the area of the parallelogram PQRS. So first of all, we know that the equation of L1, which is 3x minus 4y plus 20 equals to 0. So at x-axis, we know that y is equals to 0. That gives us 3x plus 20 equals 0. So x is basically minus 20 over 3. So which gives us the coordinate P, which is basically minus 20 over 3 comma 0. And now we will find the coordinate Q. So for Q we know that at y-axis x equals to 0, that gives us minus 4y plus 20 equals 0. So that gives us y equals to 20 over 4, that is 5. So which is basically the coordinate Q is 0 comma 5. So also we know the coordinate R, which is 8 comma 0. So we can draw a small diagram to understand the locations of the point. So R is over here, that is 8 comma 0. Then P is over here, which is minus 20 over 3 comma 0. Then Q is somewhere here, that is 0 comma 5. Then N S is expected to be somewhere over here, in a way that all these things together, like S can be somewhere like here or here or here or here. So in a way that it's a parallelogram, so that this side is parallel to this side and this side is parallel to this side. So we don't know the exact location of S, but for the time being what we can see that the area of the parallelogram PQRS is basically twice the triangle PQR. So area of PQRS is equals to 2 into area of triangle PQR. So 2 into half into, so we can use the base and height. So the base is PR and the height, let's consider it OQ. So basically we get PR is basically PO plus OR, that is 20 over 3 plus 8 into OQ is basically 5, which gives us 220 over 3. 220 over 3 units square. So now we will find the coordinate of S. So to find the coordinate of S, we can say that the vector QR is equal to the vector PS. So from here we can write OR minus OQ is equals to OS minus OP. So we are using the concept of parallel sides and the vector concept. So from here OS is equals to OR minus OQ plus OP. So OR is basically 80 minus OQ is basically 05 plus OP is basically minus 20 over 3 0. So that gives us 4 over 3 minus 5. So this is OS is basically the position vector. So we can say that the position vector is basically coordinate. So therefore S is equal to 4 over 3 minus 5.